This slide is an excellent summary of what is essential and non-essential inside the digestive system. The enzymes with the asterisks are the ones that are essential. Essentially, it's everything coming out of the pancreas. Bile micelles are essential as well because you need them to digest the fat. So the mouth makes amylase, the mouth makes lipase, not listed here, but it's there a little bit, and it's basically to make the world taste good. But you don't have a protease inside your mouth, and that's why pure protein, tastes like nothing. The stomach makes pepsin to dissolve protein, but it's not essential for life. That's why you don't need the acid. And that's why you can live on a proton pump inhibitor for the rest of your life. Everything out of the pancreas, lipase and colipase. Colipase pushes the bile away so that the lipase can touch the fat. And alpha amylase is essential out of the pancreas so it can dissolve up those proteins. Trypsin, chymotrypsin, elastase, and carboxypeptidase are all essential, as is bile that's stored and concentrated in the gallbladder, because without the bile, you can't absorb the fat. The brush border is necessary to have the disaccharidases, sucrase, maltase, lactase, and peptidases, because remember is that the body can only absorb small things. For the outside world, digestion and absorption are almost the same thing, but not for us, because we are the insiders, we are the initiated, we're in the secret frat. We know digestion means chopping up the food and absorption means eating it. The chef in the kitchen is digestion. You at the table are absorption. They're not the same, are they? Does your stomach absorb anything? I don't think so. Does your stomach absorb protein? Not mine. Does your stomach absorb fats? Nuh-uh. Does your stomach absorb proteins? No way. So your stomach doesn't absorb fats or proteins or carbohydrates. Nuh-uh. So what does it do? It's a grinding and a mixing and a mixing and a grinding, and everything that comes out of it is very, very tiny. 1 milliliter, 2 milliliter, 2 millimeter, 3, very, very small. When it pours out of me, each time it contracts, a little drop comes out. Each time it contracts, 3 times it needs to get a teaspoon, 1 teaspoon a minute. That's it? Wow. Yeah, 1 teaspoon a minute, man. Pulverize it down, and in the small intestine, the micelles emulsify the fat, and the pancreatic lipases digest it, and then brings it into the body inside the small bowel. The major end product is a position 2 monoglyceride and free fatty acids, and that's what ends up being digested out of the triglycerides. So the triglycerides does not get broken down into 3 free fatty acids. It's 2 free fatty acids and a monoglyceride at position 2. Salivary amylase begins digestion, and the amylase will continue in the stomach until the acid penetrates the bolus. And what that means is that the amylase itself gets digested. So salivary amylase just doesn't last very long. Time for you to chew. That means that's why when you dissolve bread in your mouth, you're not just dissolving it in liquid, it's actually being digested. Isn't that interesting? Wow. Taste and see. The digestion of carbohydrates in the small bowel is hydrolysis of starch by alpha amylase. And this happens in the small intestine, starts in the duodenum, continues inside the jejunum, and makes it down into teeny little parts. But remember, the splitting into trisaccharides, disaccharides, and oligo. What does oligo mean? That's the 4, 5s, and 6s. Let's say the name for that is alpha limit dextrans. The brush border enzymes, or the alpha limit dextranase, maltase, have their highest activity in the jejunum. Now, how much carbohydrate should there be left inside your bowel by the time it hits the ileocecal valve? Well, by the time it hits the ileocecal valve, there should be no starches there. If you have starches and sugars in your ileocecal valve, it's called lactose intolerance. Now, these enzymes are required for digestion because disaccharides are not absorbed. There should be no food by the time it hits the ileocecal valve. Alpha-dextrinase cleaves those bonds and produces some free glucose. You can't do that for all starches because some animals do it, but we don't unless it is actually has a particular type of bond going one particular direction. Lactase chops up lactose into glucose and galactose. And why don't you get weight loss with lactose intolerance? Because you have two other disaccharides like sucrase and maltase. And you can absorb the other sugars. Plus there's fats and protein, so you don't lose weight. You just become socially isolated because nobody wants to sit next to the person with lactose intolerance. Take that milk out of your diet. The monosaccharide end products are absorbed from the small intestine. That's all that's going to be absorbed is monosaccharides. Acid activates pepsinogen. Pepsin digests proteins, but pepsin is not an essential enzyme because pepsin is inactivated by the basic environment in the duodenum. Now, this is where we get the word Pepsi-Cola, because the guy who invented Pepsi-Cola was a medical school dropout, dropped out after the first year of medical school, just after he learned that acid activates pepsinogen. So Pepsi-Cola was marketed as an acid that would activate pepsinogen. They called it Pepsi-Cola. But the guy who invented it did not know that pepsin was unessential for life. But carbonic hydrase, carbonic acid, will actually activate your pepsinogen, so you can get increased activation of something not essential. Pancreatic proteases, such as the trypsin, chymotrypsin, elastase, are generally secreted in inactive form, so you don't have pancreatitis. And protein digestion is completed at the small brush border enzymes. And you can absorb things that are a little larger. See, unlike sugars, you can absorb dipeptides and tripeptides. But you have to still dissolve them down into ditripeptides and tripeptides. They still have to go down that small. Pancreatic enzymes are needed for triglyceride, carbohydrates, and protein digestion. And without cholecystokinin, without the pancreatic enzymes, you will starve to death no matter how much you eat. Here's a picture of what it looks like to absorb things from your intestines. Glucose and galactose go in on a co-transport with sodium. Is that active or passive? It's passive because no ATP is split. Fructose, is it active or passive? It's passive because no ATP is split. Now it does go in, the glucose and galactose and tripeptides and amino acids go in with sodium, but when it comes in on the luminal end, that's not active transport. The active transport's on the blood end, where it says ATPase. And step one is very big on you knowing that what's going on the luminal end is not active transport. It's secondary to an active transport on the blood side. So this is secondary active transport. It's secondary to an active transport that's on the blood side. What is the effect of insulin on the glucose absorption here? Insulin will not affect this because insulin does not affect secondary active transport. And that's one of the big questions for us. What is the effect of insulin on the absorption of glucose in the bowels? And the answer is nothing. Also, so you don't have to learn it twice, this is the same type of absorption that's happening in the proximal convoluted tubule. So the proximal tubule of the kidney and the small bowel look almost exactly the same. Glucose and galactose go in with sodium. Fructose just goes into facilitated diffusion. And the amino acids go in with a co-transport with sodium. This slide is a summary slide looking at how lipids are absorbed. You notice you don't need active transport or secondary active transport to absorb fats. We have an active transport to absorb bile salts, but not for fats. Fats go into the small bowel. They get emulsified by bile into micelles. Pancreatic lipase chops them up into 2 free fatty acids and a potassium 2 monoglyceride. These free fatty acids and 2 monoglycerides go in with fat-soluble vitamins. Now you know why fat malabsorption makes you malabsorb vitamins A, D, E, and K. A, D, E, and K. A, D, E, and K. Because they're all absorbed at one big globule together. And then they get re-esterified into a chylomicron, into a lacteal. And a lacteal is a specialized name for the lymph system of the small bowel, because that lacteal is enormously large to carry really big fat molecules like chylomicrons. But the absorption of fats is largely through diffusion. Remember that, diffusion. This is a summary slide to say, well, what's different at each part of the bowel? If you look, you'll see every part of the bowel absorbs sodium, chloride, and water. They're all absorbing sodium and water and chloride. That's not different. What's unique to the duodenum? Divalent cations. Calcium, iron, magnesium. Calcium, 2+. Iron, 2+. Magnesium. Is that ferric iron or ferrous? What's normally absorbed into us? Is it ferric or ferrous? The iron ferrous is a ferrous. Ferrous is the iron ferrous. Ferrous is 2+. Ferric is what makes you sick. Ferric is sick and ferrous is ferrous. That's what's unique to the duodenum. What's unique to the ileum? Bile salts and intrinsic factor. Bile salts B12. Bile salts. B12. Bile salts B12. Bile salt B12. And what's unique to the colon is the excretion of bicarb and potassium. That's what's unique to the colon. It also explains why it is that everybody with diarrhea has a metabolic acidosis. Everybody with diarrhea has a metabolic acidosis because they're excreting extra bicarb. That colon is a bicarb secreting organ. But you also see the chloride comes in. That's why you have a normal anion gap. One anion out, bicarb. One anion in, chloride. One anion out, bicarb. One anion in, chloride. Our final slide is simply to make one last little point that diarrhea is isotonic fluid. And since diarrhea comes out of the colon, and the colon is a bicarb and potassium secreting organ, you lose bicarb and potassium, making you have a metabolic acidosis. So diarrhea is isotonic, and diarrhea causes a normal anion gap, metabolic acidosis. I wish you well on your test. This is Conrad Fisher, wishing you happy studies. Don't forget that the fluid in babies is hypotonic, but in grown-ups, it's isotonic.